Okay, now we're ready for part 4. So it says we're going to continue to use the motion simulation part of this PhET simulation. And we're going to select the 50 kilogram box. Click on the values, the masses, and the speed boxes. You're going to need a stopwatch, or you're going to need your cell phone in order to do some timing. This next part may require 2 people to do. Set the slider to 100 newtons. And so while holding the slider at 100 newtons, you're going to time how long did it take for the box to move 5 of those increments. So it kind of looks like railroad ties. So you're going to let it go over 5 of those. So it's going to move 5 of the increments. And so you're going to need to know how much time did it take to move those 5 increments. And you're going to record all of this information in that data table that is down below. Okay, when the box has reached the 5th increment, you can release the slider. So then you've gathered all of your data. So the first box is the number of increments that has moved. So that would be 5. Measured force applied. Well, what did you move the slider to? How many newtons of force did you use? Okay, you're going to put that in the second box. Measured mass that was moved. Well, what was the mass that I told you that was being used in this particular simulation? Okay, measured time elapsed. So that's going to be with your stopwatch or your cell phone. Measured final speed of the box. Okay, now you can get that from when you clicked on the box that said the speed box. It should have given you a speedometer so that you could measure the speed that the box had when it reached that 5th increment. So you may need to redo the experiment now that you know what you're looking for. Okay, now we're going to calculate the acceleration of the box. So use Newton's second law. So if you know the Newton's second law, you can now calculate what the acceleration of the box should have been. Now, to get the final speed of the box, you could get that by knowing the how fast equation. So do you remember from when we did unit 3 and we talked about the how fast and the how far equations? So what was the how fast equation? It was the one that said v equaled something. So go back in your notes, find that equation. So you now have enough information to plug into that formula to find the final speed of the box. And you can compare that with the reading that was on the speedometer. So hopefully those two numbers would be very similar to each other. Okay, calculated distance that the box moved. So you can get that from the how far equation. So knowing your measured initial speed, measured measured initial speed, the acceleration, and the time, you should be able to calculate the distance that the box moved. Okay, the last thing is to calculate the distance per increment. So let's say that the distance was 10 meters and it moved 5 increments. What do you do? 10 divided by 5, because we had 5 increments. So whatever number that you get for the distance, then divide it by 5 and put that in that last box. And then the answer should be about 6 meters per increment. That's what I calculated. So see if you can get a number that is close to that number. Okay, now we're going to do part 5. So part 5 of the lab is you're going to do some hands-on experiments. So you're going to go to Google and you're going to cut and paste that web address into it. And there's going to be like 5 little experiments that you're going to do. And then you're going to write a sentence or two for each of the 5 different experiments, showing what happened when you did the experiment. Okay, then I got some post-lab questions for you to do, and shouldn't be too difficult as long as you understand what Newton's second law of motion is. Alright, so that's the lab for today, and then I will see you back in class. So, bye.